Alright, so I'm going to show you guys how a box and whisker plot works. So I'm at the website there that I gave you on the notes, and they want you to draw a box and whisker plot for the following data set. So I don't know what this is, but let's just say a bunch of people, this was their data that they gave us. Maybe it's how tall they are. I don't know. Whatever. The first thing you want to do is order the data set. Okay, so put it in order from smallest to greatest. The first thing that you want to calculate is the median. And most of you, I mean, we'll cover this later in the course, but most of you have probably heard the word median before. Median is just the number that falls right in the middle. So a lot of people, what they do is they'll take the data and then they'll cross, they'll cross 3.9 off, and then they'll cross 5.1 off. Then they'll cross 4.1 off, and they'll cross 5.0 off. And they'll keep doing that from the left and right until they fall into the middle. The median is either the number that's exactly in the middle, or if you had two numbers in the middle, let's say that 4.4 and 4.5 hypothetically were both in the middle, you would take the average of those two. So you would add them up and divide by 2. But in this case, the median is 4.4. It falls exactly in the middle. So we'll call that Q2, and what that means is the second quartile. I'll explain the quartiles here in a minute. The next two numbers you need to get, okay, so you got the median. Next two numbers you need to get are the medians of the other two halves of the data. So here's half of your data, the lower half, and then here's the upper half. What you're going to do is do the median again with the upper and lower half. So like on the lower half, we will find the median. So 1, 2, 3, 4, 5, 6, 7, 8. So the median here is going to be between those 2 points, the 4.3 and the 4.3. So if you take the average of 4.3 and 4.3, you just get 4.3. Okay? And that's what they did right here. The upper half of the data, the median is going to be right here between 4.7 and 4.8. So it's going to be, when you add those two together and divide by 2, you're going to get 4.75. Okay? So Q1, we call this the first quartile. Okay? And 4.3 is the number, the magical number here. What this means is that 25% of your data, or 1/4, which is why they call it a quartile, falls at or below 4.3, which makes sense, right? So 25% of the data here falls at or below 4.3, okay? The reason that the median is called Q2 is because it's the second quartile. So 2/4 of your data, or 1/2, falls at or below 4.4. And this makes sense if you just look at it. Half of the data falls at or below 4.4, and then half the data falls at or above 4.4. Q3 is called the third quartile, which means that 3/4 of your data falls at or below this 4.75 number. So this stuff I've highlighted right here falls at or below 4.75, and that makes up 3/4 or 75% of the data set. So now that you have the median, the first quartile, and the second quartile, you want to go ahead and graph this. Now, a lot of people might see this and think, oh, so it starts at 3.9 and ends at 5.1. I'll just go like from 1 to 10. And I'm glad that the person who wrote this webpage up wrote this little bit here. Look, so the data only goes from 3.9 to 5.1. There's not really a point in going from 1 to 10. I mean, this guy essentially goes from 3.5 to 5.5 and marks it off by tenths instead of by like ones. So instead of being like 1, 2, 3, 4, 5, so he marks it off 3.5, 3.6, 3.7, 3.8, 3.9, 4.0, so on and so forth. Okay, and that'll be a good number line for when we graph our actual box and whisker plot. Okay, by the way, they call this a box and whisker plot because you have a box and then it kind of looks like you have a cat with whiskers here. So, okay, the first thing you want to do is mark off your quartile 1, your median, and your quartile 3. So we marked off quartile 1 is this guy right here, 4.3, which he didn't do a very good job marking off because it looks more like 4.25, but whatever. Quartile 2 is going to be at 4.4, and quartile 3 is going to be at 4.75. That one looks pretty good. Okay, and then the endpoints here So these are the whiskers. These he put as the very endpoints. So 3.9 is this one, and then 5.1 is this one right here. So those are the endpoints. Sometimes you'll have endpoints that are just like off the charts. Like what if we had an endpoint that was, 48.7? So 48.7, I mean, are we really going to extend the number line and draw that whisker all the way over here? No. A lot of times what people will do is if you have really extreme outlier endpoints, like 48.7, what they'll do is they'll just take the distance here of the box. This is called the inner quartile range, by the way. So they'll take this box here and figure out this distance. So what would the distance here be between the first quartile and the second, or in the third quartile? Well, it would just be 4.75 minus 4.3. So that would be 0.45. And a lot of times what people do is they'll multiply. Oh, look at that. That's kind of weird. They will multiply the distance here, so 0.45 times 1.5. And then they'll just take whatever that is, which is 0.675, and they'll say, okay, fine, so here's this number. We're going to go 0.675 and mark our whisker. And that's only if you have like really extreme outliers. But in this case, we can just put our whiskers at the very end, okay? So you draw your quartile 1, the median, quartile 2, and then that makes your box. So you go ahead and box that in. Your whiskers are either the endpoints or the 1.5 times the inner quartile range thing that I just talked about. And then what you do is you just draw a line that connects your box to the ends of the whiskers there. And you guys should really know how to do this. I will probably ask you to create a box and whisker plot on your first unit test. I'm also going to have you create them in Microsoft Excel. And I also want you to be able to interpret them. Okay, so on this example, let's talk about interpreting them. What it means is that 25% of your data falls below the end of the box here. The next 25% of your data falls in this little rectangle here. The next 25% of your data falls in this rectangle here. And the last 25% of your data falls in this rectangle here. Other things that are important. This is the median. That means half of your data is above this, half of your data is below this. Okay. So it seems like I could tell you right now, looking at this, there must be a lot of numbers here between 4.3 and 4.4 if I actually went up to the data set, because 25% of the data falls in this little rectangle here. So let's go up and look at it. Yeah, there's a ton of data between 4.3 and 4.4 there. See how many numbers there are? Okay. Another thing you need to know, 50% of the data, or in other words, the middle 50% of people fall between quartile 1 and quartile 3. So half of your people here are falling between 4.3 and 4.75. That's what I wanted to say with that. We may, I do want to also look at, if you look at two box and whisker plots that are drawn like one here and then another on top of it, and they're like different, like maybe another one's over here or maybe another one's shifted over here. I do want to talk about how to interpret those as well. I don't have those on me right now. Maybe they'll be on the next page. I doubt it. But so here's another example if you just want to flip to the next page. And then let's see what's on the next page. Okay. Yeah, so here's an example of where you have like some extreme outliers. Like this is a data point here, this is a data point here, this is a data point here. But your box and whisker plot it might not want to extend the lines all the way over there. It might just extend the lines here. So that'll happen sometimes. Yeah, so there are different kind of weird box and whisker plots that you can get, but that's the basic intro I wanted to give you guys on that.